بسم الله الرحمن الرحيم. We finish by this question 20. Let me continue doing the rest of this section 4.3. We reach now question 28. What they want in these questions: find the critical numbers, find the open intervals, decrease, increasing, apply the first derivative test, and find our relative extreme. Oh, okay. Okay, let me start by 28, which is very clear. So I'll find what's the domain, Orion numbers, very clear. So I'll find f prime, that will be what? 3x squared minus 12x, which is 3x times x minus 4. Okay, critical numbers, f prime equals 0. So I have x equals 0 or x equals 4. And they are in the domain of f, since the domain of f are real numbers. So both are critical numbers. Now we'll check the sign of f prime. So I'll put 0, we'll put 4, take a value, less than 0, negative, negative, that will be positive. Between 0 and 4, 1, it will be negative. More than 4, it will be positive. So it's increasing, decreasing, increasing. So it's increasing from minus infinity to 0 and 4 to infinity, and decreasing 0 to 0. Okay. Also, since this is increasing, then increasing and decreasing, then I have local max at x equals 0, and I have local minimum at x equals 4. Okay. I think that's very clear. Okay, next one, 30. It's like you can open down, you can do the multiplication, or you can do the derivative right away. For sure, the domain is all real numbers. So we'll do the derivative. That will be what? Derivative of the first, which is minus something, which is minus 8 minus x. Derivative is minus 1 times x plus 1 squared plus 8 minus x. Derivative of the second one, that will be 2x plus 1. Okay, I can take x plus 1 as a common factor. What will be the remaining? Minus x minus 1 plus 16 minus 2x. Okay. So that give me what? That give me x plus 1. And there I have what? 15 minus 3x. 15 minus 3x. In other words, that will be, I can take minus 3 common factor. I have x plus 1 times x minus 5. Okay, critical numbers. F prime equals 0. So that implies x equal minus 1 or x equal 5. So these are the critical numbers belongs to the domain of f. Domain of f is the Orion numbers, so we have no problems. Now I will go to the sign diagram for f prime. I have minus 1 and 5. Take a value for minus 1. It will be what? For example, minus 2, negative, negative, negative. That will make it negative. Take 0. It will be positive. 6 to the positive, positive times minus. So it's negative. So it's decreasing, increasing, decreasing. So it's decreasing from minus infinity to minus 1 and 5 to infinity, and increasing minus 1 to 5. And they have local minimum at x equal minus 1 and local max at x equal 5. Okay, let me go to the next one. I think I have a space here. Yeah, I can do it in the next one, maybe better. F of x equal minus x to the power 6 plus 6x over 10. Well, the question is what? 32. 32. F of x minus x to the power 6 plus 6x over 10. In other words, it's what? Minus 1 over 10x to the power 6 plus 3 over 5x. Okay. That will be my question. Okay. Now the domain or real numbers, as usual. We'll find the domain first. Or real numbers, very clear. So I'll find f prime. F prime will be what? Will be minus 6 over 10. It will be minus 6 over 10 x to the power 5 plus 6 over 10 plus 3 over 5, which is 6 over 10. So I take 6 over 10 or minus 6 over 10 or 3 over 5. This is plus 3 over 5. Can take 3 over 5 common factor. By the way, this is 3 over 5 also. This is 3 over 5. So it will be 1 minus x to the power 5. And critical numbers, f prime equals 0. So I have x equal 1. Okay. So I list the one. This is 1. Before and after. Take 0. It will be positive. That will be negative. So that will be increasing. That will be decreasing. So increasing from 1 to infinity and decreasing from minus infinity to 1. No, opposite. Decreasing from 1 to infinity and increasing minus infinity to 1. And they have local max at x equal 1. Okay. Next one, which is what? 34. 34. F of x, x to the power 2 over 3 minus 4. That's it. Yeah. Okay. Domain or real numbers. Clear. F prime will be what? 2 over 3. X is minus 1 over 3. That's it. Or in other words, 2 over 3 x to the power 1 over 3. Okay. Critical numbers. Fx cannot be 0. F prime cannot be 0. 2 is not equal to 0. So f prime equals 0 will give me nothing. So check f prime does not exist, which implies x equals 0. So critical numbers, this is a critical number. It belongs to the domain of f. So it's a critical number. Okay. Now do the sign diagram for f prime. I have 0 only. Take a value before 0. Negative, it will be negative, and that will be positive. So it's decreasing and then increasing. So decreasing from minus infinity to 0 and increasing from 0 to infinity. And they have a local minimum or relative minimum at x equals 0. More problems. 38. Okay. I need to deal with 38. How do you do 38? You know what? I can do it in two ways. One way is through the calculation, where I will consider this as a piecewise function. This is one way. Another way, I know how to graph the function. I can decide about everything. So if you can graph the function, if you graph the function, that will be what? It will be at -3 and going down -1. This is -3. And the function at 0, it's what? It's 2. So it will do something like this. And this is 2. But I know the graph of the function, I know everything. So critical numbers will be what? X equal -3. Don't know if prime does not exist. Okay. And it's decreasing from -infinity to -3 and increasing from -3 to infinity. And they have a local min at x equal -3 without doing anything. Yeah. Okay. Let me do 40. Actually, I'll do piecewise function here. So I will do that. So I will not do this one as a piecewise. Okay. Let me do the next one, which is 40. F of x over x minus 5. That's mine. What's the domain of f? All real numbers except 5. Okay, what's f prime? Derivative of the numerator, x minus 5 times x minus 5 minus x over x minus 5 squared, which is -5 over x minus 5 squared. By the way, I have point of discontinuity at x equal 5. Okay. So now I will do the sign diagram for f prime. It will be what? Critical numbers. Do you have critical numbers? No critical numbers, huh? F prime equals 0 will give me nothing. 0 equal -5, that's nothing. If prime does not exist, x equal 5, which is not in the domain. So no critical numbers. No critical numbers. So now I put the number line using 5, which is the point of discontinuity. Take a value less than 5. It will be actually negative or positive. That will be always negative. That will be negative, negative. So it's decreasing from -infinity. That will be like this. -infinity to 5 and 5 to infinity. I cannot say it's decreasing from -infinity to infinity because at 5 we have point of discontinuity and we have no relative extreme. No relative extreme. Okay, now we'll go 42. 40. Oh, I need a space here. So what is 42? What is the function? Is x squared minus 2x plus 1 over x plus 1. 42. F of x squared minus 2x plus 1 over x plus 1. What's the domain? All real numbers except -1. Don't forget, I have point of discontinuity at x equal minus 1. So I need to consider that when I do the number line. Okay. F prime will be what? 2x minus 2 times x plus 1. Okay. Minus 1 times the numerator over the denominator square. Let us do the calculations. You have what? I have 2x squared minus x squared. That will be x squared. And I have minus 2x plus 2x. This is خلاص. Plus 2x. So I have x squared plus 2x. The constant is minus 2 minus 1. That will be minus 3 or x plus 1 squared. And that give me what? X plus 3, x minus 1 over x plus 1 squared. Okay. F prime equals 0. So I have for critical numbers x equal minus 3 or x equal 1. And both are belongs to the domain of F. So they are critical numbers. Now we'll put the number line. Don't forget the point of discontinuity. So I have minus 3. This is open. And I have 1. Oh, by the way, when I have point of discontinuity, I need to put this as open interval. Yeah, don't forget this. No, this is okay. It's not the point of discontinuity. When you have point of discontinuity, this is I need to make it open to be sure and know we get it right. Okay. Okay. Now take a value between minus 4, minus 3. Before minus 3, take minus 4. It will be negative. Negative. This is the numerator is always positive, so that will be positive. Between minus 3 and minus 1, and take minus 2. I get what? Positive, negative, that will be negative. Between minus 1 and 1, take 0. That will be negative still. 1 to infinity. I have positive. Take 2. It will be positive. Very clear. So it's increasing, decreasing, decreasing, increasing. So I have increasing from minus infinity to minus 3 and from 1 to infinity. And decreasing from minus 3 to 1 and minus 1 to 1. Minus 3 to minus 1, sorry. Minus 3 to minus 1. And I have local max at x equal minus 3. What about at x minus 1? We don't have anything. And local min at x equal 1. Okay. Local max at x equal minus. Local min at x equal 1. Okay, let me do the next one. What is it? Yeah, this is the piecewise function. 2x plus 1, x squared minus 2. F of x is 2x plus 1, where x is less than minus 1. And what is the other one? Yeah, x squared minus 2. This is, I have the equality here. This is x squared minus 2, and again x greater than minus 1. So that's my function. What's the domain? All real numbers. Function is defined everywhere. So all real numbers. Okay. Now check f prime. F prime. By the way, what's the number? 44. That's what be 44. Take f prime. That will be 2. If x less than minus 1, that will be 2x. If x greater than minus 1. Can I make it equal? No, because at minus 1, I have 2 and minus 2. So for sure, now we'll check critical numbers. F prime equals 0. From here, I have two things. 2 equals 0, which is wrong. 2x equals 0, so x equals 0. which is part of this domain. So this is okay. And f prime does not exist, since this is jump point and limit from right and left not equal, which is f prime from right and f prime from left. That means x equal minus. So the critical point are this and this. X equals 0, critical numbers, I mean. This and this, since the domain numbers. Now we'll put these numbers, -1 and 0, and then check the sign now. Take a value -2. -2 will be where? It will be here. And f prime will be what? Positive. Between -1 and 0, I will be here. Take a value, substitute, we have a negative. After 0, also will be here on this side, but it will be now positive. So it's increasing, decreasing, positive, and increasing. So I have increasing from -infinity to -1, and from 0 to infinity, and decreasing from -1 to 0. And they have local max at x equal -1 and local min at x equal 0. Okay. More functions. 45. I think I did it before. Yeah, it's the same as this one. So you have everything. You have decreasing, and you have the local maximum. Okay, so I will not do, since we did it before. It was in one of these old exams. So this is, we do it before, and we can finalize it. Yeah, since it's I think you can decide easily. This is increasing, decreasing, خلاص, huh? So this is increasing here, decreasing here, and at 2 I have local maximum. Yeah, I will leave it. I don't think we need to do. Now we'll do 47. 47. I'll check what will happen in 47. 47. What's the domain? Or in numbers. I have no restrictions next. Is it arc? No, this is arcsine. Oh, sorry. I was thinking arctan. Arcsine. So the domain will be between -1 and 1. I know that x should be between -1 and 1 for arcsine to be defined. Okay. Now f prime will be what? 4 minus 4 over square root 1 minus x squared. That's the f prime. So I can simplify it. That will be what? That will be 4 square root 1 minus x squared minus 4 over square root 1 minus x squared. Okay. If we take 4 as a common, so now I need f prime equals 0. So I have what? 4 square root 1 minus x squared equal to 4. In other words, I have square root 1 minus x squared is equal to 1. So I have 1 minus x squared is equal to 1. So I have x squared is equal to 0. So I have x equals 0. Okay, and I have f prime does not exist. Means I have x equal plus or minus 1, which is in the domain. So I need these values to check now the sign. So I have minus, actually starting from -1. These are endpoints, okay. And they have, yeah. The domain is -1 to 1, and I have 0 here. Check the sign now for this function. This one is always positive, so no worries. Take -1 and 0, take -½ You substitute, you get what? -½ 1 minus 1/4. That will be something. If you think about it, this is 4 square root 1 minus x squared minus 1. Well, this is always negative. If you take any value, actually -½ or +½ it will be the same, since I'm dealing with x squared. So 1 minus 1/4, it will be square root 3/4, which is less than 1. So -1, that will be negative. So I have negative, negative. So it's decreasing from where to where? From -1 to 1. I can't say that. It will be decreasing from -1 to 1, since everything is defined. Okay. And it is, do we have relative maximum, relative minimum? No. No relative extreme. But be careful. Be careful. Do we have absolute maximum or absolute minimum in this function? Yes, we have an absolute maximum, absolute minimum. And why we have an absolute maximum, absolute minimum for this function? Notice f of x, it's not an easy question, is continuous on this interval, which is continuous in a closed interval. So for sure it has an absolute maximum, absolute minimum. So how to check those absolute maximum, absolute minimum? Like what we did in 4.1. So I will check f of 0. And that give me what? F of 0 will be what? Arcsine of 0, 0. 0, so everything is 0, so that will be 0. F of -1, the endpoints, huh? Yeah. F of -1 will be 4 -1 minus arcsine of -1. What is the arcsine of -1? Arcsine of -1 will be what? When I have, that will be minus pi/2. Minus pi/2. So that give me what? 4 times -1 plus pi/2. Okay. Now I check f of 1. It will be 4, 1, arcsine of 1, which is pi/2. Okay. Which one is bigger? Which one is smaller? Notice one thing. This pi/2 is what? 3, it's 1 point something, huh? Which is 3.1/4/2. So this is negative. So this is less than 0. But here, this is positive. So this is greater than 0. So the absolute maximum will happen at x equal -1. And the absolute minimum will happen at x equal 1. Okay. Yeah, it's a special function, this one. Okay. Now let me do 49. 49 is x times 3 is minus x. You notice the functions, yeah, x times 3 to the power minus x. Yeah, each function has its things, huh? Now, what's the domain? Foreign numbers. Everything is defined, nothing to worry about. Now we'll check f prime. Actually, it's g, huh? What is it, the function? F, okay. So I have f prime will be what? Product rule will be 3s minus x plus x times 3s minus x times minus 1 times length 3. Okay, so I can take 3s minus x common factor. I have 1 minus x length 3. This is f prime. Okay, now the critical numbers, I will check f prime equals 0. So I have, let me do it in steps. 1 minus x length 3 equals 0. So I have x length 3 equal 1. So I have x equal 1 over length 3. Okay, x equal 1 over length 3. Now I will do the sign diagram for f prime. I have only 1 over length 3. This is what I have as a critical numbers. Now we'll take a value less than 1 over length 3. Take 0, for example. Who cares? If you take 0, what you will get? You will get positive. That will be positive. Take 1 over length 3. Take, for example, 2 or 1. 1, what you will get? 1 minus length 3, which is negative. So that will be negative. So it's increasing, then decreasing. So it's increasing from minus infinity to 1 over length 3 and decreasing from 1 over length 3 up to infinity. And they have local minimum, local max at x equal 1 over length 3. Oh, as I said, this function has its complexity. I need the domain, huh? I want to do the domain first. Domain of f. I need x is positive, and also this argument should be positive. Okay. So if you solve this, 2 minus ln x positive implies no ln x less than 2. Exponential is continuous, is increasing function. So I can take e. So I have x less than e squared. So x, I have 0, and I have e squared. I know x is greater than 0 and less than e squared. So this is my domain. Domain of f from 0 to e squared. Open. Okay. Now I'll find f prime. F prime will be what? F prime will be ln of u, so it will be 1 over 2 minus ln x times derivative of u, which is minus 1 over x. So it will be minus 1 over x, 2 minus ln x. Okay, now I'll put the number 9. Don't forget, the number line should be between 0 and e squared. That's it. Will f prime, will it have critical numbers? No, f prime. If I want to find the critical numbers, f prime equals 0 will give me minus 1 equals 0, which is nothing. We cannot do anything here. So now I'll have the sign. This is 0. This is e squared. Nothing, huh? So I need to check. If you take e, for sure e should be some, or 1. 1 may be easier. 1, it will be 0. That will be negative. So the function always negative. So it's decreasing from 0 to e squared, which is the entire domain, and no relative extreme, no local extreme. Okay. Yeah. Let me do this function, 56. Okay. Yeah. Maybe say f of x is what? E arctan x. What's the domain? All real numbers. I have no restrictions in x. Okay. Now, if I want to check f prime, to check the critical numbers, f prime will be what? E arctan of x times derivative of arctan of x, which is 1 over 1 plus x squared. Critical numbers, f prime equals 0 will give me nothing. 1 equals 0, which is nothing. I have no critical numbers. So what I will do, it means I need to check the function from minus infinity up to infinity. Take any value. You should get, if you notice, this is positive, this is positive. So the function is always positive. The function is always positive. So it's increasing from minus infinity to infinity. No critical numbers. And no relative extreme, no local extreme. The function is increasing all the way from minus infinity to infinity. Okay, now we'll do more problems. Yeah, but I think they are becoming more complicated now in the calculation. Okay, 58. 58 seems difficult, but no, it's not that difficult. You can deal with it. Notice these are trig functions. Before we did not do any trig functions. Yeah. So now we're doing trig functions. And he wanted this interval between 0 to 2 pi. 1 cycle. Okay. The function, if you notice, is what? Sine x cosine x plus 5. And that, this one is what? Half sine 2x. That would make it easier. Okay. Domain of 0 to 2 pi. Find f prime. Easy now. F prime will be what? Cosine 2x. That's it. So when cosine 2x equals 0, critical numbers, I need f prime equals 0. هيصير عندك what? 2x equal pi over 2 plus n pi. Okay. So x will be what? Pi over 4 plus n over 2 pi. Okay. So don't forget, I want 0 to 2 pi. Now, if n equals 0, if n is negative, I'll have a problem. It will be a negative value. X will be a negative, so I will ignore it. N equals 0, I said x equal pi over 4. N equal 1, x will be what? 3 pi over 4. N equal 2, pi plus pi over 4, that will be 5 pi over 4. N equals 3, that will be 7 pi over 4. X will be 7 pi over 4. N equal 4, I will be more than 2 pi. Will be greater than 2 pi. So خلاص, ignore it. So I have these critical numbers. I have 1, 2, 3, 4. These are the critical numbers. So now I plug them here, and I'm working from 0 to 2 pi. So I'll put pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Don't forget, I'm working with what? Cosine 2x. خلاص, I need just to check the quadrant. It's easy to decide. Here, if I put x, any value between, that will be for sure positive, which is the first quadrant, times 2. Still, I am the first quadrant. This one will be negative, since I will be in the second quadrant. Take, for example, pi over 2 times 2, that will be cosine pi, which is negative 1. And that one will be positive, negative, positive is for you to check. So I have increasing from 0 to pi over 4 and 3 pi over 4 or 5 pi over 4 and 7 pi over 4 and 2 pi. And decreasing from pi over 4 to 3 pi over 4 and 5 pi over 4, 7 pi over 4. local maximum, that will be increasing, decreasing, increasing, decreasing, increasing. So I have local maximum at what? At x equal pi over 4 and at x equal 5 pi over 4. Local min at x equal 3 pi over 4 and at x equal 7 pi over 4. Okay. Okay, that is 58. Yeah. Now we'll do 60. I don't know if we can have this space. It will be enough. Inshallah, it will be enough. What is 60? I have the domain, so check f prime. F prime will be half minus sine x. When this equals 0, so I have sine x equal half. When sine x equal half, that will be easy. X equal first quadrant and 30 pi over 6 and 5 pi over 6. So I will do the number 9. Don't forget, I'm working from 0 to 2 pi. So I'll put now here pi over 6. Here I put 5 pi over 6. Okay. Take a value between less than, this is my f prime. Less than 0, that will be what? That will be for sure negative, positive. It will be less than half. If we take any value, it will be less than half. That will be positive. Here I can take pi over 2. That will be negative. And here I can take, it will be a negative value actually, so it will be positive. So I have increasing from 0 to pi over 6 and 5 pi over 6 to 2 pi. And decreasing from pi over 6 to 5 pi over 6. Okay. Relative, that will be increasing, decreasing, increasing. So I have local max at x equal pi over 6. And I have local min at x equal 5 pi over 6. Okay. Now let me do the next one, 62. F of x equal what? Sine x minus the square root of 3 cosine x. Okay, that would be 62. So now domain class 0 to 2 pi. No worries. F prime will be what? Will be cosine x plus square root of 3 sine x. Okay. If you want to make this equal 0 to find the critical numbers, what will happen? I have cosine x equal minus the square root of 3 sine x. Or let me do it the other way. Let me do it square root of 3 sine x equal minus cosine x. So I deal with tan instead of cotangent. So that give me what? That give me, if I divide by cosine, I have square root of 3 tan x equal minus 1. That implies tan x minus 1 over square root of 3. When tan x equal minus 1 over square root of 3, it means second and fourth quadrant. And it is which angle? The 30 angle as the reference angle. So x will be 5 pi over 6 and 11 pi over 6. So we'll put the number 9 as usual. This is 0, this is 2 pi. Here I have 5 pi over 6. Here I have 11 pi over 6. Check the sign. Let me plus, minus, plus. Okay, so it's increasing from 0 to 5 pi over 6. I put the sign, Hassan, no need to waste time and do it every time. خلاص, you can do it. Take values. Sometimes you need to change it into degrees to take values easily. 5 pi over 6 and 11 pi over 6, decreasing, increasing, decreasing, increasing. So I have local max at x equal 5 pi over 6. And you have local min at x equal 11 pi over 6. Okay. 61. Yeah, hopefully it will be not difficult. F of x cosine squared to x. Oh, it has a lot of critical numbers. Yeah. No. Yeah, 61. Yes, yes. Okay, f prime will be what? F prime will be 2 cosine 2x times minus sine 2x times 2. Don't forget times 2. 2 cosine 2x, derivative of cosine 2x, to the minus sine 2x times 2. So that will be what? That will be 2 sine 4x. Double angle. Idea. This is f prime. Or you can leave it as this, and you can take sine 2x. Now, if you check critical numbers, yeah, you can do it like this. So I need f prime equals 0. When sine 4x is equal 0, I need to check when sine 4x equals 0. So I need to check when 4x equal n pi. That means x will be n over 4 pi, n pi over 4. Okay. Yeah. Now we'll check the, I'll take n 0. I'm getting pi over 4. Take n equal 1, 0. I mean, I'm getting 0. خلاص, 0 is not there. Forget it. I will start with 1. X equal 1, n equal 1, I mean. I have x pi over 4. N equal 2. X equal pi over 2. N equal 3. X equal 3 pi over 4. N equal 4. X equal pi. N equal 5. X equal 5 pi over 4. Still, I did not reach 2 pi, N equal 6. X equal 3 pi over 2. 6 pi over 4, which is 3 pi over 2. N equals 7. X equals 7 pi over 4. Wow. So we have 7 critical numbers. Okay. So we list them. Yeah, I will not write increasing, decreasing. I will leave it for you. This is 0. This is 2 pi. Yeah, this is pi over 4. Pi over 2. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. Or 7 pi over 4. I will put the signs. Start decreasing. Increasing, decreasing, increasing, decreasing. And I put the sign positive, negative. This is would be negative, positive, negative, positive, negative, positive, negative, positive. خلاص. So you know decreasing, increasing, you know relative maximum, relative minimum. I will leave it for you. Yeah. Just the calculation is a little bit complicated. Okay. Yeah, I think I will stop here. Yeah, we'll still have some functions, but just functions, different functions. If you notice, just we have now the square root something with the e. Yeah. Okay. So I will stop here, and I will stop the recording. Yeah. Thank you.